In these videos, we want to find critical points, minima and maxima of functions of several variables. And so here I have a surface, f of x and y, which is equal to xy, x minus 2, y plus 3. And to find minima, maxima, or saddle points, we first need to find the critical points. And you remember the critical points are those where the partial derivatives are equal to 0. That's what I do in this video, and then in the next video then I classify them to be minima, maxima, or saddle points. To find the critical points, I need the partial derivatives of this function. Now we have learned partial derivatives quite a bit, so I need to differentiate this function with respect to x, keeping y constant, and then with respect to y, keeping x constant. So let's start with the x derivative. Now x appears here and here, so I use a product rule. I differentiate the first term first, y is a constant, and then x minus 2, x plus y plus 3, plus, and then I keep the xy term constant, and I differentiate the x minus 2 with respect to x, which is just a factor 1. And then y plus 3 remains. Here we have common factors, we have a y common, we have a y plus 3 in common, and then we have an x minus 2 there and an x there, so this gives a 2x minus 2. Or we can write it a bit more nicer, 2y, y plus 3, x minus 1. For the partial y derivative, again a product rule, because y appears here and there. So then from the first term we get x, x minus 2, y plus 3. From the other term, we keep xy, we keep the x minus 2 as a factor, but then the y plus 3 is differentiated, it gives a 1. Here are common factors as well, the x is in common, the x minus 2 is in common, and then we have a y plus 3 there and a y there, so it is 2y plus 3. Alright, so these are the partial derivatives. Let me carry them over to the next page, so here they are written again. Because for the critical points, I have to set this equal to 0. So let's start with fx. Fx is equal to 0. And now we are lucky, this is written already in a product form, so we can see the zeros just by looking at it. So, right? So if y is 0, we have a 0 there. Or if y is minus 3, we have a 0 there. Or if x is equal to 1. And now for each of these possibilities, we need to check the second equation and see when this is 0. And we need to find all possible combinations between fx0 and fy is 0. The best way to do is to start with the fx equation as I did, and now work our way through these three possibilities. If y is 0, in the second equation, we get fy becomes 3 times x minus 2. Okay, so the 3 comes from the last bracket. Y is 0, the 3 remains. Now this is 0 for x is 0 and x is 2. Then if y is 0, we find two values for x which make fy is equal to 0. We find 2 points. The one is x is 0, y is 0, and the other one is x is 2 and y is 0. Let's look at the next value. So if y is minus 3, again we look at fy, but now we sub in y is minus 3. X minus 2, y is minus 3, then we get a minus 6, plus 3 is a minus 3. And so now this is equal to 0 again for x is 0 and x is 2. So we find two more critical points. X is 0 and now y is minus 3, and x is 2 and y is minus 3. So at this step it is easy to mix up x and y's. Okay, x is always the first entry, y is always the second entry. So then these are two more points which we find. And we have a final point here. If x is equal to 1 from upstairs there, then fy. Now I sub in x is 1. So there's a 1, there is a minus 1. So this is minus 2y plus 3. And this is 0 for y is minus 3 half. Right? Right. Okay. So then we find a fifth point where x was 1 and y is minus 3/2. Alright, so we find 2 green points, 2 blue points, and 1 red point. So in total we find 5 points, which are critical points, which means they're candidates for being minima or maxima, or maybe not. Maybe they're saddle points. So here I summarize this. The surface has 5 critical points as I just computed.